Welcome. Thank you for joining us today. If you're on this webinar, you're attending one of the EarthX webinar series training. This series has a number of different opportunities for education and awareness. And today's event is on electromagnetic pulse. This is sponsored by the Electric Infrastructure Security Council. The council is a 501c3 nonprofit that works with industry and governments at all levels to increase our overall resilience of the electric grid and obviously the supporting other industries. EarthX is moving into its fourth year this year in 2020. EarthX actually stands for Emergency All Sector Response to a Transnational Hazard. It is an international exercise. Last year we had over 40 countries participate and several thousand people that in various forms took advantage of the EarthX exercise. We'll talk a little bit about EarthX as we go forward. One of the reasons we picked EMP to focus on this year, it is a hallmark for the council. It's the reason we got started. But this year's threat for EarthX, we're moving away from last year's threat, which was a regional natural disruption to the electric grid. This year, we're taking on two of the more nefarious threats, EMP and cyber. EarthX will be online 1 September through 31 October. We do ask you to sign up and play in that period. Last year, when we ended the exercise, we actually had requests to continue playing for several months. We won't be able to do that this year, so please register, tell your friends to register, and pick your date to play. But with that being said, let's go ahead and jump into the meat of the presentation, and we'll come back to EarthX at the end. It's my pleasure today to introduce an absolute expert for the council on this subject and many other subjects. Mr. Frank Koza serves as the Energy and Electric Sector Coordinator for the council, and it's my pleasure to turn this over to him. Frank, it's all yours.
Okay, John, thanks very much, and good afternoon, everyone. First, I have to counter John a little bit by saying I'm not an expert in EMP. My role at the EIS Council is to be an editor of a forthcoming publication that we hope to put out later this year on EMP, and it will discuss not only the threat itself, but also testing results that have been done, and certainly will focus on practical techniques that can be applied to protect from EMP. So with that said, let's get right into it. First of all, what is EMP? And you kind of see my simplified definition here about EMP. It is I'll put very in front of it. It's a very complex electrical and magnetic interaction with the Earth's magnetic field and also with the atmosphere that induces currents and high voltages from the pulse. I have to tell you at the outset here that I've borrowed heavily from publications that are out there, and I've got a slide at the end here that will provide more information if you want to get into this deeper. But certainly the EMP Commission reports that have been published over the course of years here are very instrumental in providing information on EMP, and also a set of reports that was done by Meditech for the Oak Ridge National Laboratory. Those documents really get into the topic very deeply, and certainly I would recommend those documents too if you want to get into this very deeply. But quite frankly, today we just have time for what I'll call a high altitude flyover of the topic of EMP, and we hope to kind of raise awareness here about EMP itself, what the threats are, not only to the power system, but the other infrastructures as well. And then finally, we'll introduce the topic of how do you mitigate it. And I'll mention right here that we're planning for a second session like this on June the 11th. And at that session, we hope to have some of the experts in protection on the call with us. And we will discuss how do you mitigate EMP? What are the things you can do to protect the infrastructures from the impacts of EMP? So mark that on your calendar. June 11th, we'll have a second session that will talk about EMP protection. So to get back to the topic of today, it is a complex phenomenon. So the question is, one question right off the top is, how do we know about the impacts? And I mentioned here probably the two most important things we've had to draw upon. First of all, there were atmospheric nuclear tests, both by Russia and the US back in the 1960s. The US test was called Starfish. It was conducted out on Johnston Island out in the Pacific Ocean. And the Russian test was done in Central Asia. And quite frankly, the Russian test is probably more important because it was done over land. And the impacts that were seen it's more important, I guess, to have that over land. And I guess there was some instrumentation done of that test. And the results of that have been shared between the United States and Russia. So that basically is the fundamentals of the pulse itself, what we know about it and what the impacts are. John, next slide, please. Okay, so we're going to focus on a couple of sources of EMP here. And I have to tell you at the beginning, there are other sources of EMP. Lightning is certainly another one, but we want to focus here on high altitude nuclear detonation and also IEMI, and I'll get to that in a minute here. But okay, high altitude nuclear detonation, we're talking about a nuclear device that would be detonated above the atmosphere, and we're talking on the order of like 50 to 150 kilometers above the surface of the Earth. I think everybody's aware that if you have a nuclear detonation at ground level, there's certainly a tremendous amount of kinetic damage, but this is a device that would be detonated above, would not result in kinetic damage on the surface of the Earth, but would generate this very, very high intensity electromagnetic pulse toward the Earth. The intensity of that pulse is predicated on a number of things, and I've tried to list them there. We've talked about altitude a little bit. Energy yield is another, and you should understand at the outset here, we're not talking about a tremendously sized nuclear device here. Actually, the smaller kind of devices are ones that can generate extremely high pulses and could be dangerous as well. Also, the amount of gamma ray output it provides. And I should mention here, the impacts are variable due to the Earth's magnetic field. Now, on the right side, I do have a diagram here and this is a study that was done. And I'll just mention to you, you can see how the impact attenuates as you get away from the detonation point above the Earth. But the other thing to keep in mind is that pink shape there, just to the south of the detonation point, that is where we would expect the EMP be the greatest, and that's because of the orientation of the magnetic field in North America. So it's not a constant impact. The impact attenuates as distance from the detonation point, which seems kind of intuitive, but the impacts can be variable, and that's what that device is meant to depict. Now, down below is the IEMI device, or what's called intentional electromagnetic interference, or basically EMP in a suitcase. These devices obviously provide a much more local impact, but can provide very, very high EMP pulses and can basically duplicate or even exceed the EMP that can be provided by a nuclear detonation. But like I say, it's much more local as opposed to the nuclear detonation in the upper atmosphere. John, next slide, please. Okay, so let's talk for a minute about the EMP threat. Now, this graph is going to require some explanation here, in that it is a log-log, so-called log-log plot, whereas every tick there is a factor of 10. So on the X scale or the horizontal scale is time, and on the Y scale or the vertical scale is the electric field intensity. So to put this in perspective for you, you can see times. Let's talk about the horizontal axis for a minute. The time zero, we basically is 1 second. You can see that's over on the right side of the chart here. And then if you go toward the left, we're going into fractions of a second. And you can see when we get to the E1 pulse, which is the first or the very high impulse and fast part of the the pulse, so to speak, you're talking about very, very, very fast. And just to put that in perspective, 10 to the minus 3 here is milliseconds. 10 to the minus 6 is microseconds, or a millionth of a second. And then 10 to the minus 9th is a nanosecond, or a billionth of a second. So the EMP pulse really comes at us in 3 different kind of pieces, if you will, called E1, E2, and E3. So from a time perspective, you can see how fast this occurs. And then if we take a minute and look at the vertical scale, you're talking about volts per meter. And you can see that when you get to the top of the E1 pulse, you're talking on the order of 50,000 volts per meter. And so just keep that in mind as we look through this. So first of all, the E1 pulse, extremely fast. I put ultra fast here as the description. Basically, it's over in a microsecond. And I want to put that in perspective for you from this standpoint. When you blink your eye, that occurs in a 1/10 of a second. So if we go back to the bottom scale, the horizontal scale, you're at 10 to the minus 1 is an eye blink, if you will. So that's just to give you an appreciation of how fast this occurs. So again, E1 in a microsecond, but it's a very, very, very high amplitude electric field there. And then as we move along, E2 is a slower but lower strength field. It's a pulse that's been compared to lightning. So you can see that occurs in fractions of a second, and certainly lower kind of amplitudes there. And then if we move to E3, E3 is even slower. And in E3, you're getting to the point of seconds to minutes. Certainly a slower, lower strength pulse that is similar to space weather. And for those who are unfamiliar with space weather, let me digress here for a minute about that. Occasionally, the sun will emit what's called a coronal mass ejection, basically a massive cloud of plasma that gets ejected in space. Now, sometimes it will be ejected at the Earth, and when that cloud of plasma interacts with the Earth's magnetic field, you can have induced currents in the ionosphere and also induced currents in the ground. So E3 is similar to that process. In an EMP device, the magnitude or the amplitude of those pulses is likely to be higher than space weather, but we can think of it that way. It's a relatively slow, lower strength kind of a pulse. John, next slide, please. Okay, so what are the impacts to the power system? The device that tends to get a lot of the focus here is in the picture that I have on here on the left. It's a digital relay. These kind of devices, and we didn't pick Schweitzer out for any kind of special purpose here. Schweitzer happens to be a major manufacturer of digital relays that are on the system, but there are certainly other manufacturers out there. But anyway, these devices are solid state electronic devices, and unfortunately I didn't put a picture of the insides of these things, but if you can picture a whole bunch of electronic circuits, the solid state electronic circuitry, that's what you would see inside the case here. But it's basically a solid state device. And these things are located, I mean, all over the power system. There are thousands of these things on the high voltage and extra high voltage transmission system. Their job is to provide protection for the equipment that's on the power system. So let's digress a little bit from that. The relay tends to be at the end of the line in the sensing system. So there is a device that's out in the substation, out on the transmission line, that's taking a signal off the device or the line itself. It is bringing that signal back to this digital relay, and the relay is determining whether situation normal or it's a situation of a problem. If it's a problem, the relay will actuate. It will cause a trip signal to go out to circuit breakers. It will take the line out of service and protect the equipment and the line from damage. from overloads or other kind of system damage. So that's the purpose of the device. What happens here in an EMP is that that device can obviously be radiated by the EMP pulse that we just talked about, and also the control cables that connect these devices, which tend to be copper control cables, will conduct energy from the pulse into the relay itself. So those are the processes, if you will, that can cause damage to the relay. So it's both radiative, that is being in the field of the pulse, but also the fact that the control wires act like an antenna and basically conduct energy from the wire into the device itself. So it's got that double kind of threat. Now, what we've learned so far, and a number of tests have been done by various people on these relays, it turns out, and I'm going to generalize here, which is dangerous, but the radiative threat is probably less of an issue for the relays than is the conductive threat. Now, you can't see the whole relay here, but I can tell you it's encased in a metal case. That metal case is probably installed in a rack inside the substation's control room. That control room may have either be built out of sheet metal or have metal shielding on it. All of these factors would enter into trying to reduce the radiative energy, I'll say, that the relay would face. So those kinds of radiative impacts tend to be less of an issue for the digital relays. The bigger threat is probably the conductive energy. Now, I mentioned that there's a copper control wire that takes the signal from the sensor and brings it into this device. The bad news here is that control cable can be 50, 100, 200 feet long. So if you think about the amplitude of the field that I talked about, conducting that kind of energy on a copper wire toward the relay here is definitely a problem. So all I can tell you at this point, the testing has been done. The relays, some of the relays, it looks like will fail. They certainly have the potential to fail. And I'm brutally oversimplifying this because there are so many factors involved with how that energy. I mentioned the radiative energy being transferred into the control room of the substation. The factors involved with conducting the energy, that is the orientations of the cable, the shielding on the cable, the grounding of the cable, all that kind of stuff enters into this. But certainly the conductive energy issue is a potential problem, and will have to be dealt with on the electric system to be able to protect these digital relays from damage in an EMP event. John, if we go to the next slide, please. The other issue here is relay misoperation, and the relay misoperation basically is caused by the same thing. And what I wanted to do here is basically separate the issue of damage. Now you can have the relays, catastrophically kind of fail, where they fail and they need to be replaced. We can also have a situation where the relay misoperates, and that is the signal from the sensing device into the relay can be changed by the EMP currents and flows that are in there to the point where the relay doesn't get damaged necessarily, but the relay will misoperate. It will either trip devices that shouldn't be tripped or miss fault kind of currents that should be picked up and cause the system to be taken out of service. So this is the situation where if enough of this occurs, then you get in a situation where you could trigger a wide-scale electrical outage on the system. I've got a picture here, obviously, from the 2003 blackout that occurred in the Northeast. If we got into a situation where a significant number of the relays misoperated, you could certainly trigger what's called a cascading kind of outage that would take out significant portions of the system. And that's exactly what occurred in the 2003 blackout, when the electrical outage kind of rippled up from northern Ohio through Pennsylvania and New York into Canada and down through Michigan and caused that northeast blackout. So relay misoperation is another particular concern that deals with, that has to do with the digital relays. And I should mention in passing here that the relays are certainly not the only devices in the substation on the power system that we need to be concerned about. There's a whole host of electronic devices, not only in substations, but in generating stations and all, that we need to be concerned about, where solid state electronic devices are in place with the potential for control cables to feed conductive energy into the device, and also to pick up the radiative energy from the pulse itself. So there's plenty of electronic devices, and I kind of chose the digital relays explanation here to kind of focus on that, because that tends to be the device, when you look at the transmission system, that most people tend to focus on. John, next slide, please. I would be remiss if I didn't talk about large power transformers here. We have a picture of one of those on the left here, and you can kind of appreciate the size of this. There's basically a full-size van sitting behind it here in the picture. These are massive, massive devices on the power system. And I mention this because I talked about E3 and the fact that the slow pulse, the pulse of the E3 is such that it's in a time domain where it starts to cause core heating in transformers. The transformer is basically large amounts of metal that are magnets with two coils of wire, and basically they're used to either step up voltage or step down voltage. The transformer looking at here is a large one, but pretty indicative of the kind of large transformers you see in substations. In the EMP event, they are likely to face core heating based on the pulse itself. Now, I mentioned space weather. The amplitude on an EMP device is likely to be higher than space weather, so that's bad news. The good news is there's so much metal here that to heat that up to a point where it would be a problem does take time. And I mentioned here the fact that if a transformer is old, if a transformer has had very complicated and difficult cycling, if there are maintenance issues involved with the transformer, that the EMP E3 potentially could be the kind of, I'll say, last straw that kind of causes catastrophic failure to the transformer. So we shouldn't ignore that as well. That's another potential out there, although, like I say, you need to heat the transformer up takes a significant amount of time. John, next slide, please. Okay, now the electrical system is not the only concern here with an EMP. And this diagram on the left basically comes from the EMP Commission Executive Report. It kind of depicts the interrelationships here of the various critical infrastructures. And we're not going to go into the diagram in tremendous detail, but I do want to mention, let's look at the electric power that is in the upper right of the diagram. And I just want to highlight one or two impacts here. If you take the electric power diagram, you can see power supply, and there's an arrow going toward oil and gas. Now, I would assume many people are familiar with the fact that there are now electrically powered natural gas compressor stations on the gas transmission system. So here's where you have one source of interaction with another of the infrastructures. And quite frankly, natural gas fired electric generation is probably the fastest growing, I'll call it, generation technology being used today for the production of electricity. So you see that arrow coming from oil and gas back to the power plant on the electric power side. So that's just one example of how a long-term electrical outage here would impact potentially the gas transmission system that then rebounds onto the power system, and that it would cause potentially the inability of some gas-fired electric generators to operate. The other one I'll point out here, there's an arrow going from the electric power over to the communications. And certainly all the switching offices and facilities on the telecom system are electrically powered, and we're going to talk about that in a minute. But this diagram is really only to highlight for you that there are so many interdependencies between electric power and all the various critical infrastructures here, that a long-term outage from an EMP event would certainly have many, many ripple effects into the various other infrastructures. John, next slide, please. So let's talk about telecom for a minute. Telecom is incredibly important to the power system in that if we're going to start to put the system back together, if we're going to go into a restoration and recovery program, which we would have to do in an EMP event, telecommunications becomes incredibly important. You can't start black start units. You need to have communications to put facilities back in service. The lack of that would just cripple the ability of the power system to restore itself and put electric power back into service. Now, the good news here is that most telecom facilities do have some kind of backup power capability, but that capability generally is for on the order of hours or days and not generally available to cover outages that would go on for days or weeks or even longer. So telecom is certainly one impactful infrastructure that we need to be concerned about in an EMP event. And they obviously also have a whole lot of solid state electrical devices that could be impacted by EMP. John, next slide, please. Another one is banking and finance. Virtually all financial transactions today between banks and other financial institutions occur electronically. That's just the way the world is today. And again, with telecom, where backup power capability exists, it's generally pretty short term and requires periodic refueling. And then we believe refueling could be challenging in a long-term power outage situation as well. John, next slide, please. Fuel infrastructures, I already kind of touched upon electrically driven natural gas compressor stations. Certainly when you look at oil refineries, other fuel infrastructure, pumping stations, they are very heavily electronic control systems and electrically driven pumps and compressors. So again, they could be backup power capability, but it's generally short term. So fueling infrastructure would be particularly challenged in an EMP event. And we've seen that occur in the various kind of catastrophic events like Hurricane Sandy that occurred in the Northeast some number of years ago. So fuel infrastructure, another critical infrastructure that could be dramatically impacted. John, next slide, please. Transportation, same kind of situation. Reliance on electronic control systems for the most part. And transportation is one where there are just very interconnected kind of supply chains here involving multiple modes, all relying on IT systems and telecom for effective execution. So you take electricity away from that, and right away you've got some serious challenges for keeping transportation infrastructure going. John, next slide, please. Food infrastructure, I guess I don't have to talk about refrigeration, but certainly, again, food production becoming more reliant on technology, and the food storage and distribution systems require an interconnected change of various infrastructures to make them effective. John, next slide, please. Water and wastewater, another one. This happens to be a photograph for those in the DC area. This is the Blue Plains facility that DC Water has. It basically handles all the wastewater for not only the District of Columbia, but also various counties around in Maryland and Virginia surrounding the district. So it also relies heavily on electronic control systems. There are a number of electrically driven pumping facilities, not only at this facility itself, but in pumping stations around the area that feed the wastewater into the system. So I think you can appreciate that loss of electricity here kind of really seriously hampers water and wastewater, and is certainly critical to the maintenance of human life in these kind of a long-term electrical outage situation. John, next slide, please. I wanted to introduce finally here that the issue of the next session, if you will. We talked about it. It's scheduled for June the 11th. We hope to have a number of people that are expert in the issue of how do you address EMP threats and how do you mitigate the threat. I have one slide here that kind of talks at very high level about some of the things that need to be done to address it. The first is resource prioritization. I think it's not necessarily realistic to think you can protect everything everywhere. So you kind of have to pick your targets very carefully. We think you have to select the most critical facilities for protection, and we think that the protection focus needs to be on those facilities that sustain human life and prevent mass migration. Mass migration, when you think about that, could be particularly catastrophic. We got in a situation where an EMP took out very critical areas, and we needed to, and the outage was so severe that we needed to mass migrate people. I think you can imagine what kind of a human catastrophe that could trigger. And then I talked about radiative energy and conductive energy. For the radiative energy, metal, any kind of metal enclosure has the potential to provide the protection against the EMP from the radiative energy perspective. Continuous layer of metal, and when I say six-sided, it's got to be continuous. It's got to be all around the device or facility, and penetrations into that enclosure need to be very carefully treated to ensure that the energy doesn't come in through a penetration and negate the effectiveness of that enclosure. So there are facilities that are now implementing shielding and hardening. And I should have mentioned at the outset here that the U.S. military has been all over this for a number of years, have developed techniques and facilities to deal with this. And now that information is now becoming available to the commercial industries, and certainly that work is being applied in places to try to address some of these issues. And then finally, I mentioned the control wiring situation and the fact that it's an antenna that can conduct the energy, and there are methods and techniques to deal with that. Surge protectors and filters can be installed to prevent the conduction process. There's also the possibility of replacing those copper control wires with fiber optic cables that really are immune to EMP. So there are a number of techniques out there. We hope to bring, though, at least on a summary level, those techniques to you so you get an appreciation of what's out there. We also hope to share test results. I mentioned earlier that testing has now been conducted on a lot of devices. Certainly the military has done testing for a number of years, but I can tell you that commercial testing now is taking place. I want to, highlight the cooperation that the EIS Council has been getting from the Defense Threat Reduction Agency. They've been extremely cooperative in working with us to kind of facilitate testing of various devices. And in our upcoming handbook that we hope to put out, the results of that kind of testing would be available and of use to the utility industry to kind of guide protection from EMP. So again, mark June 11th on your calendar. At this point, that concludes my part of the presentation, and I want to turn it back to John. Oh, I should mention, thanks, excuse me, John. I mentioned resources. Here are a couple. I mentioned the EMP Commission report. This is only one of them. There are several of these reports out there, but at least this gives you an entryway into at least one of the reports. And I did make mention of the Meditech report. And again, just like with the EMP Commission, the Meditech report, there are several of the Meditech reports. I just listed one of them here from 2010, but one of the Meditech reports I know can be accessed from the FERC website. So these documents are certainly excellent resources for you if you want to go deeper, not only into the EMP pulse science, if you will, but also the techniques for protection and mitigation. So those are certainly great resources. If you want to learn more, there's where you can go. John, thanks, and back to you.
Hey, Frank, outstanding job. I take exception with your statement that you're not an expert. You definitely are expert. So we appreciate you bringing that information today. Let me recap a couple of points that came up. Someone asked about the slides. Yes, we'll make the slides available to everybody that registered for this session. We are recording this session and we'll make that video available on our video wall. So for everybody who registered, you'll get a link to that website, and you'll also get the slides, either a link or the actual slides will come out. Some questions came in. We're going to do our best to answer those questions. As Frank talked about, we have several scheduled training webinars coming up in our EarthX series. And what you have on the screen right now is a list of those events and the dates that they're going to go. The best way to find out about the training that we're offering moving into EarthX is to register for EarthX. We encourage everybody in the world to register and play the individual and families lane of EarthX. But if you're in an industry, we have 7 functional areas that you can group into, or 38 different lanes that you can sign up for. So there is a flavor of EarthX for just about everybody. You'll notice here that we do have these webinars coming up. Some of these are cutting edge. Frank's going to be conducting the one on EMP resilience, but as he mentioned, we're going to bring in 2 or 3 subject matter experts who really understand the theoretical parts of EMP and then what's being done worldwide to protect and harden. So that's going to be a great opportunity. The first time we've been able to get those people on a webinar, so we're excited about that. Then Frank's going to come back with some of his team and talk about grid resilience, talking about something that his work group has established, which is the minimum core utility requirements. Very much cutting edge work. I mentioned early on that EarthX this year has multiple themes. The first theme is EMP, but the second one is cyber threat. So we're going to take time and actually walk people through what cyber threat is all about. We're going to offer some incident management training for non-emergency management organizations. And then probably the thing that set us up early on for this year, and the COVID situation has just highlighted it, is to really take a hard look at global supply chain threats and make sure that everybody has got a feel for what's going on. I think we've all learned something about the PPE supply chain issue, but this one will look at much broader issues as well. And then we're going to focus in on global continuity issues and requirements, and we're going to do a kickoff webinar where if you signed up for EarthX, we're going to bring you into the new world on that webinar on 25 August. So anyway, if you want to know more, if you want to stay in step with us, go ahead and register, and that will ensure that you get all the announcements. I do want to take a second to make an opportunity here for all of you all to give us some feedback. We started on EarthX 2020 back in November and actually briefed it to our council leadership in December and got their stamp of approval. And one of the things that we talked about coming out of some work we did both in Washington, D.C. last year and also the United Kingdom and Scotland, which is this whole idea of the things that are fraying at the edges called the global continuity framework, where things are not maybe as aligned as we need them to be. EarthX Phase 3 is going to take a very hard look at this and try to develop a number of issues that we can start working on holistically with our teams, and hopefully you'll join our team and give us some feedback. So Phase 3 is going to give you a chance to play through some of these global continuity issues. So kind of the good news is Phase 3 is actually going to start today. What we're going to do is at the end of this webinar, we're going to send you a link to a survey through your email. And we're going to ask you to think about these issues that we all have a focus on right now because of the COVID issue. COVID is really a black sky class event. It's not truly black sky, because if it was, there would be a long duration power outage. Now, interesting to note, there have been a number of power outages that were near black sky, but they were very much localized. One in the state I live in, one was out in Utah in the second week of the big COVID issue. We want to give you a chance to give us some ideas to think about and to fold together, because we're building a commission set of panel discussions that are going to kick off in July and August to focus all our thoughts and bring in some industry experts to actually talk about these areas that we just need to do better at as a population. We are weak in some areas, and COVID has only highlighted that. So we want to do better. And obviously, from the council standpoint, we're a big believer that we've got to work cross-sector. Some of those continuity areas, just to probe for a second, have obviously supply chain we talked about. Frank mentioned the critical lifelines. FEMA issued a critical lifeline effort about 2 years ago. It's really starting to take life. At the local level, though, that critical lifeline becomes just the pivotal point of whether you're going to be able to respond and recover quickly or not. And then we've had this definition that's just propped up on essential worker status. I'm almost positive, out of all the exercises I've done over the last 15 years, grocery store clerks never rose to the level of an essential worker status. But coming out of COVID, we see that that's true. Frank mentioned quickly that the energy supply is critical for food supply. It actually makes up a significant part of how we move food and grow food. Food supply is an issue. We've all seen that recently. The most recent thing is the issue with meat and the cattle market. One of the ones that's been a long enduring issue for the council is, how do we improve our ability to share information and trust information? Obviously, we're concerned with recovery areas for progress. And from the council standpoint, it's not just recovery, it's the restoration process, which is not something we talk about or teach in many of our circles. And then obviously COVID has pointed out once again, alert, notice, and assessment is critical. And we want to come back to, how do we share information that is sensitive but has to be verified? So those are just a handful of continuity areas. I'm not going to read you these slides, but the text on here, but this is an example of the questions you're going to get. We're only going to ask you a handful. They're going to be open-ended, and we're interested in your best thought. So rather than send them to you right at the end of this presentation, you get a little break and then you'll get them in email. Do us a favor and reply to those. And if you have any other questions or want to know anything else about what we're doing at the council, I would tell you to stay tuned. The best way to stay tuned for the remainder of this year is to register for EarthX. We're using that central logon to push a lot of information out. But right now, we can't tell you when the EarthX commission is actually going to go online. So if you register, I'll ensure that you get those messages. But definitely stay tuned with us. We're pulling in some really heavy hitters that have a great set of ideas to probe what we need to do and how we need to change some of our society and just become more resilient, which is really our watchword. If at any time you have a question about anything that the council's doing or EarthX, you see our email there. It's very simple, earthx@eiscouncil.org. And to register, you have the link there. Again, you will get these slides via email with a link to the video once that's done. But I would encourage you all to invite your friends and your family and those in your professional network to go ahead and register for EarthX. It is free. It is cross-sector, and you'll be part of one of the world's largest resilience exercises in history. It is going to be very dynamic this year, and we've got a few ways to change up the normal exercise format. You'll actually deal with cascading consequences through basically what we call a Monte Carlo selection process. So you may play the exercise multiple times and never get exactly the same injects. I appreciate everybody staying on the call today. I appreciate Frank. Again, great job. I hope you all will register when the link is up for our follow-on series. And we look forward to seeing you all and seeing you play EarthX. Take care, and everybody be safe.